All right, in Unit 3-4 review sheet number 35, we're going to graph the function y equals half tan t on the interval of negative 2 pi to 2 pi. With these tan functions, it's important to mark the point that corresponds to the base function where the values of negative 1 and 1. That's basically where it's a and negative a. The asymptotes and the zeros. So make sure those are clearly labeled. So the first thing I'm going to do is find the period. Since b equals 1, our period for tangent is pi. And tangent is centered around the y-axis. So our vertical asymptotes are going to be at half pi and negative half pi to get that period to be pi around the center axis. So I'm going to, let's see, we're going to go from negative 2 pi to 2 pi. So I'm going to scale my axis so let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. I'm going to use 8 because I like quantities of 4, so I can split that into fourths easily because I use the rule of fours to do these. Okay, and then let's see here. So it's centered around the y-axis. The width of the period is pi. So if this whole width is pi and it's centered at the y-axis, that means this part is going to be pi over 2. Half of it's on the right and half of it's on the left. So my asymptotes are at negative pi over 2 and positive pi over 2. Let's do asymptotes in purple. Let's see, asymptotes. Pi over 2 and negative pi over 2. And the periods, pi, so it's going to repeat after, see, the period of pi has 4 little tick marks. So another pi is going to be 1, 2, 3, 4 more over here. So there'll be another asymptote right here. And the last one will be way over here, but that's not actually part of our graph, so I'm not going to erase it. It would be here, but our graph's only going to go up to 2 pi, so we're not going to even include that. It just doesn't want to erase. I don't know why. It's stirred. Okay, and then let's see, another one, 4 ticks back, 1, 2, 3, 4. So here, so we'll have half a period on the far left and far right of each of those asymptotes. Okay, so that's our asymptotes. Asymptotes, we want to label those. So I want to make sure you clearly label those. So they can be, you can write it like this, t equals 3 pi over 2, and just label each of them. T equals pi over 2. Or you can actually just write a list of your asymptotes like this. All right, next thing is our zeros. Our zeros are going to be halfway between the asymptotes. So there's a 0 in the halfway mark there. There's always for tan, if there's no shift, then there's going to be a 0 at the origin. And halfway between each of the asymptotes. And remember, there's an asymptote over here that we didn't draw since our graph actually ends there. We can draw it in and just erase it. I just want to make sure my final answer doesn't have it because the directions say to only go 2 pi to negative 2 pi. So I'm going to kind of sketch that in there lightly and then erase it so that we know, just to kind of get some symmetry to the graph. Okay, now what's the next thing? So that's our zeros. So we did our zeros, so you can list your zeros too, since it says to clearly state them. So zeros are at negative 2 pi, negative pi. These are all t equals pi and 2 pi. All right, and then the next thing is, let's do green for our value of A. A tells me how stretched out it is vertically. So here A is that value out in front, so that's 1/2. Now that corresponds to the -1 and the 1. In the parent function, A is 1. And halfway between the 0 and the asymptote, the parent function goes through that point at 1. For this function, since A equals 1/2, we're actually going to move that down to here. So between the 0 and the asymptote, it crosses, the graph will go through that point at 1/2. And then in the negative direction, it'll also go through that point at -1/2. So my asymptote, my graph looks like this. So halfway between the 0 and the asymptote. Now remember, on the far left, we only have half the period, so we're going to go from the 0 to the asymptote on the right side, but on the left side, this side, we're actually not going to graph. Remember, it's there, but since our interval is going from -2 pi to 2 pi, we're actually not going to include that part of the graph. All right, same thing on the right side, except this time we're going to use the bottom half of the graph because it's including the lower half of that period. Okay, so I think, let me just double check we have everything we need. We stated the period in blue. We stated the value of A. We got the zeros and the asymptotes. And the point that corresponds to -1, 1 is this point right here, which you can call, let's see, it's halfway between pi and 3/2 pi. Let's see, what is that? That might be easier. Let's see. Might be easier to call this one. Half of pi over 2 is what? Pi over 4. So the t value is pi over 4, and the y value is 1/2. So that's that point that corresponds with the -1 and 1 on the home function, on the base function. And you only need to label one of those, or else it gets kind of messy. But just to let me know that you understand how the graph is not, it's compressed actually, 1/2 instead of 1. So this one would be, oh, again, it's kind of hard to figure out that one. Okay, so I think that looks good. Yeah. And just for comparison's sake, I want to show you. So this graph is y equals 1/2 tan of t on that interval. And just for comparison's sake, I want to show you what, let's do gray, tan looks like. So that is the one that has the same period and the same, there's no shifts. The only thing that's changed is that 1/2 is in front. So that changes that stretch. So the original tan function looks like this and like this. So you notice the difference is the green one is compressed by a factor of 1/2. All right, and that's all.